My name is Ed Yost, and I'm a graduate student in the University of Tennessee Natural Resources PhD program. And today I'm going to talk about how fire intensity, seasonality, and frequency affects red maple seedlings in an experimental plantation. So red maple, you may know, is a common tree of the eastern deciduous forest. It is one of the most brilliant colors in the fall season, and it is a common tree. It's classified as a softwood. This tree has become more abundant in the eastern forest over the last 150 years. The reasons for this is because of insects and disease outbreaks and the suppression of wildfire. Also, red maple is a generalist. It doesn't grow in a specific environment. It has the ability to grow just about anywhere. It has a tolerance for pH, and this can grow in just about any soil type. Its original range is from Newfoundland to Florida, west to Texas, and north to Minnesota. And within this range, it has increased considerably over the last 150 years to the point now it is the most important tree species in the eastern deciduous forest. It is a generalist. It can grow in different environments because it also produces a lot of seeds. The seeds are a double samara fruit. They're the little helicopters that we see in the springtime. And one tree can produce up to 1 million of these seedlings in every other growing season. One of the reasons that red maple has become so successful is that it produces a lot of seedlings. It leaves out earlier than other trees in the springtime and produces the little seedlings that look like helicopters. As red maple produces its seed in the springtime, it has the advantage of the whole growing season. When we look at oak and hickory, they produce their fruit in the autumn. They have to overwinter and then sprout in the springtime. In the meantime, red maple of that season has already had seedlings on the ground that overwinter as seedlings. This advantage is also of red maple is that it sprouts profusely. After a disturbance, such as logging or fire, it sprouts out from the root system and produces many little sprouts that get into the canopy and outcompete adjacent trees that are growing there as well. So these give this tree a lot of advantage. If you have a forest and you're trying to grow oak, you may find that red maple is already present in the stand. Red maple is a shade-tolerant species that can grow under the shade of other trees. When there's a gap in the canopy, red maple can achieve dominance in the canopy by filling these gaps under all that new sunlight that's coming in on the ground. It can fill those gaps that were normally taken by oak and pine that are lost. It can fill those gaps and grow up into the canopy. In many cases, it has achieved canopy dominance in the stand. Red maple is a component of both the early, mid, and late successional forest, and it can grow well in the shade as well as in openings, and as well as a canopy dominant in an old growth forest. Fire has been used to control red maple and to try and reintroduce oak, but it has had mixed results. So the basis of my research is to understand, is the survival of red maple seedlings affected by fire intensity, the season of burning, or by the frequency of burning? To understand this, we established a plantation in 2016. This plantation is made up of 3 sites, and each of these 3 sites is one block. Within each of these sites, there are 7 plots. The plots have been randomly assigned within these plots. One is a control, and the others will receive a treatment. There have a high intensity fire and a low intensity fire. They're also assigned a season, a spring season, a growing season, or a dormant season in which they will be burned. In each season, a high and low treatment will be burned in each of the sites. In every other year, this burning will be repeated again to obtain frequency. to study the effects of the frequency of the fires have on the trees. After one treatment throughout the year of each of the spring growing and the dormant season, after a year will be skipped, and then the treatments will be repeated again in the same plots to obtain an understanding of frequency of burning. Since there are no fuels present in these plots, the fuels had to be brought in from outside and artificially arranged. We've used a thermal imaging camera to determine the temperature and duration of the fire. And we use different types of fuels to achieve a high and a low intensity fire. The first fuel was maple leaves, which provide a temperature of 700 degrees. The fire, when they're spread uniformly across the plot, lasts about 10 minutes in length and duration for the low intensity. And for the high intensity, we mixed maple leaves with pine needles and then put one by one wood strips across in a grid pattern between the rows of trees. And this achieves a temperature of about 1600 degrees maximum and a duration of 15 to 20 minutes. So we're studying the two different intensities of fire on these red maple in the different growing seasons. We're measuring the survival rate of seedlings, the intensity of fire, the variance between the seasons, and the frequency of burning. This is a picture of what the infrared camera shows for the fire in the high intensity plot. And fire is patchy, and there's areas of this where the fire does not burn the trees at all, and there's areas where it burns more intensely. So fire is a fairly blunt tool when used on the landscape because not all areas get burned for different reasons of topography and moisture or just the way the wind's blowing that day. So we're looking forward to some results of the burns here I can show you in the plots. Okay, behind me I have a plot that was burned in the dormant season, and you can see that there was some top kill in the stems, but most of the carbohydrates and resources of the tree were underground at this time. So the effect is that most of the trees have just sprouted back and pretty densely. So there was not as much effect here in the dormant season from the intensity of fire as the nutrients were stored underground. On this plot, this is a growing season plot, and this was a high intensity fire, but as you'll notice, it's a little bit thinner than the previous plot in the dormant season. These trees had a lot of nutrients. They were actively growing at the time. There was some top kill in here, but the sprouting is much more intense in these trees. So the burning during the growing season, during the summer, just influences the sprouting habit of the tree. So burning may not be as effective in the summertime. On this plot, this is a spring burn, but this is the second time this was burned, so it's the second frequency. You can see that there's quite a reduction in red maple in the springtime. It's putting out all its resources to grow those new leaves and buds, and when you burn it at this time, it seems to have a greater effect. My statistical analysis will give me a greater detail, and there's more to follow on this research as we look between the intensities of the high and low and in the different seasons and the different frequencies, how often we burn. The take-home message for this is that fire may prove to be a useful tool in controlling red maple seedlings, although with maple, the larger it gets, the harder it is to control with fire. But in areas where it's just establishing, or in a clear cut where you have lots of new sprouts, fire, especially frequent fire in the springtime, may prove to be a useful tool.